Okay, so in the last session, what we have learned is about the final few chapters of exception handling. And we have also learned about using scanner instead of buffer reader and all those stuff, input stream reader, which is far more safer to use than the above than the other two. And then we started just with the theory portion of the multi-threading, why we will like to use multi-threading and what happens when you start a thread. What is the runnable interface? Okay. And then there is directly, there is another, that is the class, that is thread, which is you can extend. So thread you can extend and you can implement at the same time runnable, but both at the same time you do not need to do, because you do not need to extend a thread and then implement runnable, because both are the same. So either you extend a thread or you say implement runnable. But there is some advantages of why you use a runnable interface, because that exposes few more things that thread doesn't expose. Let us see the first example regarding the thread. So you have gone through a bit of the theory that we have learned the previous session, right? I do not think I need to repeat them. So let us see through an example how thread behaves. What is the thread and how do we start a thread? Okay, let's see the thread demo. Here we are actually discussing about the thread class. Thread class now show being non-thread classes how hi and hello being displayed sequentially. So we are going to show you how the thread classes hi. This is one class hi, and there is another class hello. So we will see that hi and hello will be displayed sequentially. Another thing we will like to see is that a thread method sleep suspends a class which is also a thread from the sleep period, for the sleep period. That means between two threads, I can have a gap. I can have a waiting period or a sleep period between the two threads, because once you have invoked the threads are out of your control. That means now it is between the CPU, the time slicing. The time slicing means how the CPU will distribute the time between the threads. That CPU has an algorithm that is called the round robin method. Okay, so that way it will give you the slicing of the time. But apparently for the user, because that is so fast, the whole thing happens so fast, executed so fast, hardly the user will understand that there are two parallel threads or four parallel threads running together, and each of them, as if the user will see that the threads are running. I mean, everything is being devoted to that user, but it is not the actual fact. If there are four users, the four users are being fed or serviced with four different threads, but the user is transparent. User doesn't know that the CPU is slicing the time between all the threads. Are you getting me? I think the guy who was not very good in English,
Yes,
Himanshu. No, not Himanshu. He's not joining the last few classes. After he had given that exam, I would like him to join as well, because he was trying to understand few things, and I was also trying to explain him sometimes in Hindi. But these guys are not joining. I don't know why.
Shashi sir.
Shashi, Shashi. So Shashi is not joining. I don't know why. And Himanshu also. Are they losing interest or what? Am I being very difficult in explaining? I don't know, but
No, sir, some other issue, sir.
Oh, okay. Maybe. Okay. Fine. But if you happen to speak with them, just let them know that they are, of course, going to get the videos. That is not an issue. But at the same time, whether they are in progress or not with whatever being taught here. That is very important for me to understand. Okay. Anyway, let's see. So we will see that there is a sleep time between the two threads. Otherwise, we will not be able to control it. Show how two threads run parallel using each class as a thread inheriting the thread class. That is, the thread class is the main class, superclass, which each of these classes will inherit, and how they run in parallel. So how just be extending a thread class will not make the functionality of parallel processing automatic. That means just you have extended a thread doesn't mean that you have started using the parallel property of the threads in automatically. So you have to do something else other than just inheriting the thread superclass. What are that? You have to do a start, which is going to, in turn, it is going to actually start the run, and there is a join method, and there are so many other methods. Ashish here, I have to leave and join again. Audio issue I'm facing. Okay, okay, Ashish. So now what I see is did Ashish join? Oh, it's Rashikar. Okay. See what we have here. We have a package. You know about package. And in that package, there is a class called high, which is now trying to extend thread. So this makes the class not a normal class. As you know, it makes a class a thread class. And within that class, we have sort of an empty method show. Once the class extends thread, it has to override run method of the thread. So this is an empty show. I don't know why we should give anything like that. But first and foremost, you have to implement or override a function or a method called run, because that is the point. Because when you say you want to start high, the object from this class, then you have to say, you cannot directly say run. You cannot directly run this thing. What you have to do, you have to say start. Start is one method under thread, which in turn will start run. Run is a method under the implementation interface, which is called runnable. So Ashish has finally joined. Fine. Okay. So runnable thread implements runnable, and your class extends thread. So your class is also implementing runnable, and runnable have a method called run. So thread, whenever you say start for this thread high, it is actually going to run. You have to start the run function. That is the main function actually. Every thread must run this run. Here what we are doing, we are trying to print high 5 times with a normal for loop. And after that, there is a sleep time 50. 50 means 500 milliseconds. It will suspend the thread. And I am enclosing this sleep because I know there could be an issue. But it is generally, if I do not give this try, if I use sleep, the compiler will give me a compilation error. Just a warning that, see, you know that sleep is not going to give a problem, but I want you to enclose the sleep method within a try catch block. You already know about try catch, so you understand that why you need to enclose it. Though you have say, see here, I have not given any message because I know out of 100 times this sleep will function without any error. But I am restricted by the compiler to give a try catch enclosure for the sleep. I cannot use it. If I take this away, I will get an error. Okay, let's say I give this, then I give this. See, immediately you see that there is an error. Can you see that? Unhandled exception type interrupted exceptions. Interrupted exceptions. So these exceptions are interrupt because you are interrupting. Something is running, okay, and you are using a interrupt method called sleep. That method, you cannot start doing that without a try catch block. That is mandatory. This is a compiler level unhandled exception. Because if you try to run this in the runtime, you will be facing an unhandled exception immediately. So compiler, the very beginning is warning you that you cannot do that without a try catch block. And why, you will ask me a question. This is an interview question actually. If you want to use sleep of a thread function, sleep. So why will you need to, what else do you need to do? Can you do it on a single line? That is, can you directly execute the sleep method? The answer is no. We have to execute the sleep method only by enclosing with a try catch block. Yes, I will not be able to, I'm not giving any exception message because I know that there won't be any exception, but this is a framework I cannot avoid. This is the convention. Any questions? So I will say between each for loop of high, printing high, there is a sleep. Okay. Now we come to the next class. Similarly, the hello class extends thread, and hello class will try to run and implement run. I am similarly doing the 5 times hello, and between each hello, I would like to give a 50. Okay. 50 means 500 milliseconds. Milliseconds is very small fraction of seconds. We come to the class thread demo. That is the main class where you have the main function. You are creating one object out of high. You can do that. So obj1 is an object of type high. Similarly, obj2 is an object of type, it's a thread object. This obj1 and obj2 are thread objects. Why thread objects? Because you have extended thread. obj1 is a thread object. Okay. And obj2 is also a thread object because you have extended thread. So if it's a thread object, that is it is not an ordinary object, it is something else. So you have to do obj1.start because you have extended thread. Now, start will automatically call run method spawning of a thread from the main thread. So whenever you start an object called obj1, which is a thread type. When you say start will immediately call run method and run method of the thread. But the run method you have overwritten. So you will run this method of high or hello. Now obj1 is high, obj2 is of type hello. So you start and you say that there between this, okay, what I do, I will entirely close this. I do not want right now. I'm making this commented out. So high will be executed. So 5 times high will be printed very fast. And 5 times high hello will be printed very fast. I will not try to give any gap between them. Okay. So I am giving, so it is always better to give it in one line because I am not writing anything in the exception, in the catch. So better why to waste few lines on this. Yeah. So one line. I am not giving any between two hellos. I am not giving any gap, any sleep time. But here, between two threads, between object 1 and object 2 start, I am giving a sleep time of 10, that is 100 milliseconds. Such that object 1, I'm giving enough time for all the object function to be executed, then only it will start. So I'm holding this object 2. Once this finishes, it will start. Let's see what happens. Okay, first of all, let me say I am not giving any try. I am not giving any sleep. Let me execute this. Can anybody tell me what will happen if I am not giving any gap between object 1 and object 2? That is between these two threads. What will happen?
Sir, it will be executed parallelly. If we keep the sleep method, then first obj1 started, it will execute it. Then after 10 milliseconds, the obj2 start object will execute.
So you mean to say that when I say obj1 dot start and obj2 dot start, these two are dependent on each other. But if this will complete, then only this will start. The previous day I have said that, you see, whenever this is being spawned by main, this main thread gives birth to two child threads, obj1, obj2, and this main thread waits. It does not do anything. It has started the two child threads. So it will start in the background. It will wait in the background. It will not do anything else because it has distributed its work. Otherwise, it had to work. If there were no threads, it would be only that one thread, which is main thread, will work. Now, main thread will go to sleep or wait in the background because it has given birth to two children, and these two children is going to work for the family. But as you said, it is not right because both are threads. So these threads are not dependent on each other. That other class, the previous class, I said, everything in this world is asynchronous. Asynchronous means they are not synchronized. Okay. So they will have their own time slicing. Object 2 will have its own time slicing and will operate separately. And this will have its own time slicing from the CPU and will operate separately. Now here I am using this laptop. This laptop is having only one CPU. It may be a dual core, but it is one CPU. So I mean that CPU has been divided into two cores, but still it is one CPU. So what will happen in this case? Both the threads will start together. There is no gap in between, and therefore they will start running parallelly. So I do not say that and that CPU, one core CPU, is going to give some time for this, some time for this. How it is done, that is a separate algorithm. That is a round robin algorithm. So that is separate topic. But somehow the CPU manages to give some time for this, some time for this. But you will apparently not feel any difference whether this child is getting more attention from the mother or this child is getting more attention. No, both are getting equal attention from the parent, which is the CPU. Some algorithm happens. So when I run this, do you expect all the highs to be printed first and then all the hello? Though our objective is that I will first print all the highs and then I will print all the hellos. But with this structure, will I be able to control the threads? I do not know how CPU is giving a time and how fast this thread will work. It is not dependent on this thread. Let us see. Oh, good. See, I have printed all the highs first and then all the hellos. And I have not given any time between. Did I give any time in between the hellos? No. Okay. Let me first try to now, my objective is already fulfilled. Somehow they have performed parallelly. Sorry, but not parallelly. Now it is parallel. See, this is unpredictable. You cannot say that first of all the highs. Let me take this on the right hand side so that it is better to. Now you can see it fully, na? Can you see it fully?
Yes, sir.
Yeah. So I have taken it on the right. So the output terminal is on the right. I can see because it is going to vertically display. It is better to show it that way. So I can see on the left hand side, we have the code. Why did it happen like this? Now the question is, see, I was supposed to get all the 5 highs because this has started first. And yeah, though it has been started also, but it is definitely started first. So I was expecting that all the 5 highs to be printed first, then I will. So it is sort of a synchronization. I wanted to achieve some synchronization, but finally I see that it is async. Async means I have no control that one high was printed or shown only after all the hellos have been printed. So it is not in my control. Again, I execute this. This time I got all the highs. So it depends. I don't know. I cannot predict. You see now, first all hellos are printed, though hello started. So are you seeing the magic? That these are threads, and that is why you have no control. See, you are supposed to get all the 5 highs first and then the hellos. But see what happened? Sometimes it was happening 5 highs in the beginning and maybe the 4 highs and 1 high in the very last. But here, see, this unpredictable pattern of how which one is going to get the time slicing first. Because they are threads. But for you, it doesn't matter because you wanted to get all the hellos printed as well as all the highs printed. Okay, let me execute it again. Now you see 1 high, then 5 hellos, and then 4 highs. So it's unpredictable. But you want to give some prediction, or you want to you write your program with some predictability. So I'm introducing a sleep time between start, object 1 start, object 2 start. So I'm ensuring that first of all, this will stop for 5, at least for some seconds, not seconds, milliseconds, such that this will complete its job and this will then start. So 10 is a big number, you know, the 100 milliseconds is quite a big number. I think I will achieve this. I will first fire 5 highs and then 5 hellos. Let me see if that is achieved. Sorry, I have to save this and say this. Yeah, and now I keep on running. Most of the time, why? Because this 10 milliseconds or 100 milliseconds is quite a big number because it is so fast. The CPU is so fast, it will immediately execute. So within 100 milliseconds of sleep time, object 1 has completed its task, that is printing 5 times. Okay. Now you increase it or make it 50. And this one you make it 5. Let's see what happens. Okay, all 50. Even that is also sufficient. See, first of all, it is completing all the 50 highs, then only hello. So 100 milliseconds is quite good time. Not a single time it has failed. You see, all 50 times it is printing high, and then hello. So as many times as you want to wish to run. Now what will happen? Let's say I come back to 5, which is quite less time. But now I increase it to 100 sleep time. Sleep time 100, or let's say 50. I will achieve that. It's quite a big time gap. So always I will ensure that. But what happens if you keep on increasing it? You see, there is some gap. After 5 highs are printed, there is some, you can see now that there is some effect. What will happen if I give it 1000? It's quite a big number. You see, there was some gap. Can you see that after the last high, it waited for some time? Then it printed all the 5 hellos. If I had increased it to 10,000, that is a big number. You see, there is a lot of gap. Milliseconds means 10 seconds. 10 seconds is a huge number for a CPU. Are you getting me? Now I want to give a sleep time of 0 seconds or maybe 1 millisecond. Sorry. Let me see whether we achieve synchronization. Till now, yes. Till now, yes. Till now, yes. Till now, yes. 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 So 1 is also good. Of course, if you what happens if I give -2? Now you see the synchronization is broken because my sleep time is less than 0. I mean, I'm not only giving a negative sleep time, I'm saying that I will not be governed that maybe it has started earlier. Yes, the first high will be printed, but after that, whenever this starts, there is no control between these two threads. So there is a threshold. So that threshold may be 10 for this particular program. Okay. Now, are you getting me? So that is the way you want to, first of all, have some control between two threads, introducing sleep. But always remember, if you give something very high or something very low, then again the synchronization will be lost. Okay. Now, what happens? Let's say I am introducing a sleep time between the between printing of each high. Let's see, and if I give yeah, okay. You see, I have again lost. See, if I have not given this, then this was in synchronization. That means all the 5 highs, this sleep time of 10 milliseconds was, I'm sorry, not 10 milliseconds, it was 100 milliseconds. This was quite enough for printing all the 5 highs and then the 5 hellos. But when I had made this one slow, that means between 2 highs, there is a sleep time of 50 milliseconds or 500 milliseconds. Then what happens is, between 2 high, immediately this will be started. So you see, 1 high is printed. After that, 5 hellos. That 50 milliseconds is quite high for this high between 2 highs. So in between, the second thread had kicked off and printed all the 5 hellos. Are you getting me? So that way you have introduced the concept. So did you understand what I'm trying to explain?
Yes, sir.
So sometimes you want to control it, sometimes you may leave it. It will be printed or it will be executed as you do not wish to control it. Let it be async. Like here it is asynchronous. You do not have any control. Let us move to the second concept, runnable interface. We have seen that we have used a thread class over here. Now we will see the runnable interface, because after all, the thread actually implements the thread. When you say extends thread, this thread class actually in turn implements a runnable class, a runnable interface, sorry. So thread runnable interface. What is happening? Here we are going to take some time, because we are also, you have learned about Lambda expression, na? So you won't take much time. What we are going to do is, we are saying that I have a class hi. I will like to implement runnable, but doing that also means that hi is of type thread, because after all, whenever you are implementing runnable, you are actually extending thread as well. But this has an advantage, because when you say implements runnable, because after all, you are, just 1 minute. Sorry. So the advantage here is, you are directly overriding the run method, which is there in runnable. As I said, you see, whenever I am placing my cursor over runnable or whatever that clause, you are seeing that it is coming from java.lang.runnable, and it is a functional interface. It is not only an interface, it's a functional interface. What I do, as you have known, that you press the control and you go here, you take the cursor, the mouse pointer over here, and you say open declaration. Whenever you say open declaration, you will see an interface called runnable. It is an interface after all, but it is at the same time, it is a functional interface. We have known that functional interface is the prerequisite for functional interface is a prerequisite for, suppose I am the interviewer and I'm asking you that if I have an interface which is a functional interface, what is the advantage? There is an advantage, right? Otherwise, why will you use a functional interface? Because it can have only one abstract method. And because it has only one abstract method, I can directly implement as a lambda expression, with a lambda expression. I do not need to create any class or do anything. I can directly implement this run method. You have learned that. You try to implement your knowledge. You see, I cannot go because this is one interface designed only to have one method called run, which is an abstract method, and therefore it is a functional interface because it has only one abstract method. And since it has only one abstract method, we can use lambda expression, because in lambda expression we know a lot of things. We know that this is a functional interface. It will have one abstract method, and that is one method which are already there in this interface, and we know that the name is run. So we can avoid so many lines of code. Isn't it? We have learned that. So there is no need for a separate class, as this already has been implemented as Lambda expression. Because of non-use of multiple inheritance in Java, we implement a runnable thread and extend a class. So here, what I have said that I want to implement runnable interface. And I know in that runnable interface, there is one run method. Just now we have seen. But I want to implement that in my own way. I customize that run method. How do I want to use it? Yes, I can do it on my own way. What I'm trying to do, I am printing 5 highs. Fine, that is all. Another class called hello hello. Also similarly, they see previous thing we have learned. Hello extends thread and high extends thread. Here I'm saying the same thing, but I want to do it with runnable. And I want to show you the implementation of Lambda. So this high is runnable and hello hello is also implementing runnable. Within this, I want to print 5 hellos. First of all, let me close this. I do not want to introduce between 2 hellos. I do not want to introduce any skip type. Now, I am in the main class. I am saying I'm creating an object called obj1. I am saying new high. Similarly, just ignore the way I'm deriving to the Lambda expression. Just for the time being, just try to forget it. Now, similarly, it's very simple. Is I am trying to have another object called hello hello by instantiating with new and creating obj2. So if I have done that, now remember obj2 and obj1 are a runnable interface, implements runnable. So they are also threads. But here the advantage is I can directly run. See there, I used start because we have extended thread, isn't it? You have said start. But since I am implementing runnable, which has a run method, I can directly go to run. It will take less time for me. So obj1.run, and I can introduce a thread. Similarly, it is just like the previous example. But here I am directly using run because I have implemented runnable. And I'm saying obj2.run. Okay. So let me execute this. What do you say? Can I execute this? And let me clear this. Let me run this. Yes, I am getting the same effect. All 5 highs and 5 hellos. Why? Because I have given a sleep time between obj1 and obj2. But here I am not using start. You see the advantage. Again, I do not introduce any sleep time. So there, okay, maybe this time. You know why this is happening? Because this high directly goes to run. That's why it is almost every time it is in sequence. But though I have not given any sleep time. Was there any sleep time here? No, there is not a sleep time any here. But still it is running like it's a sequence. It is not breaking for a single time. Okay, let me give a negative at least to just see that they are asynchronous in nature. So run method is so fast because you have directly gone to run. So now it is almost in synchronization. That is the advantage, that you, without introducing a sleep also and negative sleep also, you are making the thread run so fast that high, whenever it starts, it almost immediately in a zip, it completes all its action of printing 5 highs. That is the advantage. All the 5 runs. Okay, you introduce 50. Let me see. Still it is printing all in sequence. So fast it is. So you understand the advantage, right? Anyway, I would like to concentrate now on how we make it much more, like a I cannot control it. It will be synchronized almost because you have directly run. Anyway, now I will use another way. I'm using a Lambda expression. Going to use a Lambda expression. So what I'm doing, I am just not doing anything with this. First of all, I say I am saying a runnable, this interface, I can directly, we have learned that I can create an object with a reference to an interface, but actually with a class of, so this class, which is implementing runnable, I can have a reference of runnable. I can create an object like this. Better to reference runnable interface and instantiate the class object. Now, why I have done this? Because I want to use the Lambda expression. So the first step, what I do is I introduce this. So in introducing this, what I can get is I also make this runnable object 2, and I will introduce the first step. This is not a Lambda expression. This is just an anonymous class. You've learned that. Okay. So if you want to do that, you have said that you are creating this one, but now what I'm doing is it can be a duplicate one. So therefore I just take it out. I have created this object through runnable. So I do not need to mention it again. Okay. Let's see the first step of Lambda expression. I have created an object with a reference of runnable. Now I'm saying that this object 1 is a new runnable. Can I do that? As if this is an anonymous class, because this is after all not a class, this is an interface. But we are just giving it a name with the name of an interface, as if this is the constructor function. But there is no constructor for any interface. You know that. Since we are trying to use an anonymous class, what we are doing, or you can just close this. I do not need. I can directly go here and say, what do I say? What do I give here? I have to reference that interface, runnable, right? So now my definition is complete, that this object one is runnable, And as if this runnable interface, this is a functional interface, as if is a class. I'm using a constructor function, but there is no constructor function. That's why this is called, this entire thing from here to here, this entire thing is called a anonymous class. You have learned it earlier. Sometimes somebody is familiar with giving a bracket at the very side of it, or some programmers are very comfortable doing this. Right? So this one refers to this one. This one is a braces for this one, and this one is for this for. Correct? So it is much more readable. Now it becomes much more readable. So what we are doing, we are trying to create an object on the fly, in the fly. That means this is a runtime anonymous class. We are defining the class and it is used only one time. Since we know we can do this because this is runnable, is an interface. Runnable is an interface. This is an interface. So therefore this is a this is a functional interface. So I can have an anonymous class out of this runnable interface. You already know that. So we can see how it runs with an anonymous class. First step, let me go by steps. Similarly, here we can, for object 2, we can remove this and say runnable here. Similar concept, runnable object 2, new runnable, and you do the similar way. Yeah. So this is the run method of class hello hello. Similarly, this was the run method of class hi hi. So runnable, but this entire thing is called an anonymous class. Anonymous means no name, because runnable is not a class. So I cannot give a class any name. Anonymous class. Similarly, here we know that this is an anonymous class. Anonymous because there is no name. Fine. But it is exactly like a class because it is saying that it's a constructor function. Let's suppose this is a constructor. Runnable is a constructor function of a runnable class. Okay. Before going to the second and the third step, let us run this. We have created object through an anonymous class, object 1 and object 2. Therefore, we can use it and we can directly say run. So this run is actually calling this method run. Followed? Because this class, this is a class starting with no name but ending with a semicolon. Remember, you have to give a semicolon because this is after all a class within a class. So therefore, I have to give a semicolon. This is a syntax. You cannot avoid it. But within this class, there is a method called run, and I am directly calling this. I can do that. Object 1.run and object 2.run. But will it run? Let us see. It should run. Yes, I'm getting hi and 5 hellos. That is what I wanted. That was the next expectation. Now we come to, so any questions up to this? You are not responding anything. You must be having some questions. Arnav, Ashish, Deep, Rajshekar?
No, sir.
No, sir. No, sir.
Are you sure?
Yes.
So runnable interface, then we are trying to, now we have seen the use of anonymous class. Then, although you already know all these things, anonymous class, Lambda expression, but I am using this as a privilege to revise the topics again. Now, once we have seen that this runnable class, the anonymous class works, I'm getting the result. Now, my next step is I will go for, or better, I will give a this thing. So in the second step, I would like to use the lambda expression in a way. And finally, in the third step, we will see the shortest form of the lambda expression. Here, I'm saying that, yes, fine. Runnable object 1, fine. Equal to, now I all know this, that runnable, I know runnable and void run. Up to this, I know, because this runnable interface, just one second. Hello. আমি একটা ক্লাসে আছি, ওকে, আমি এখন বলতে পারছি। Okay, so this portion up to this I know absolutely, because I know that we are having a runnable interface, which is a lambda functional interface, and functional interface having one abstract method which is run. So up to this I know. So if I know something, why should I repeat it? That is the fundamental of lambda expression. So I know up to this, so I keep the opening bracket, that is the function brackets, I keep it open. I know this is the run method, run, but I do not mention because there is only one run method within the runnable interface, functional interface. I give a functional arrow. This is the syntax. This is how in JavaScript, this is double arrow. It is called this in JavaScript. But in Java, it is single arrow. And I keep everything else as the same, like the run. Here to here, I keep it same. So similarly, here I have given the same output. This is the second step. But let's see, we go step by step. Similarly, for this one, I keep it. Okay, let me, for this as well, I take this out. I want to run it with the second step. And what I do, I know that I'm going to method run, and the same thing, I just use hello instead. But here I do not give any sleep time. Here also I do not give any sleep time. So can I run? Because still the object is obj1 and obj2. I still can use run directly. Let me see, it should work. Let me clear this out. So see, I am getting the result. Similarly, last step, that is the third step, what I do is the actual implementation of the lambda expression. We are halfway in the lambda expression, but this is not the full. So lambda expression, my idea is to just reduce the number of code lines. So what I do, I go to this. First of all, I clear this out and then go to the third step. So everything I have commented out. We will only concentrate on the third step. So the third step says that I do not need to, because after all, this object 2 and this thing is the runnable interface, but runnable interface is again, this thread also implements runnable interface. So what I do, I remove this. I want to use this. I'm giving, instead of obj1, I'm saying thread 1. I'm directly using thread. And within that thread, because thread also implements runnable, so I say lambda expression for the object 1. So T1 represents object 1. I can give any name to any object. So I say that this new thread and here thread is, there is a class. So I can always, thread is a named one. It's a named class. So I will not say this is an anonymous class, but the rest, thread implements a runnable interface and with a method run. So that entire thing is within lambda expression, and this portion, because I have multiple lines, I cannot avoid this. So finally, you are enclosing this thread. This is the thread. What is that? This called? If thread is a class, what is this called? New thread means. Am I getting a bit difficult here? Thread is a
constructor.
Constructor. Very good. So as simple as that. It's a constructor, and that constructor is nothing but a function. And that constructor is, now I am using that with a lambda expression with all these anonymous things. Because I know that the thread, after all, is, you see, under that thread, can you see that this is a thread constructor and with a runnable target. Runnable target. So what is that runnable? Is that runnable interface? Very simply given. Or you can go to here and say open declaration with the control and this thing. You see that public thread. See, public thread is the class and runnable thread is the parameter. So I can I say this one as a parameterized constructor, where you are putting a parameter.
Yes,
Not
yes.
that, yeah.
Yes, sir.
Yes. So in that runnable, since it is a runnable target or runnable interface, that interface has a method. That method is called run. And you have given nothing because you have used lambda expression. So you know that you can use the run method. This is the run method, and run method actually does your activity the way you have defined that run method. Because abstract method does not define anything. You are using a very fantastic way of doing that. Thread is a class. You are creating an object of T1 with the thread class and with the new constructor thread. And thread has a runnable target. And what is runnable? Runnable is an interface. That interface has a run method. So everything is linked up. And without mentioning the run and everything, you are using lambda expression, because the runnable target or runnable interface is a functional interface. So many things are linked up. So this makes the thread very fast. And what is that run method? Nothing but you are trying to print high 5 times. I don't want to give any sleep time. Correct? And you are closing this thread, this entire function. This is a constructor, and the entire, this one is a parameter. So this constructor is called a parameterized constructor. See, we have learned all these things earlier. Now we are seeing the practical implementation of that knowledge. So my object becomes T1, which is a thread. Now this is the similarly for object 2. So I remove this. I say thread T2 similar to thread T1. Only that the difference is hello I'm printing. So this is nothing but a run method. Now I will have to remove this because I am no longer running obj2 and obj1, and directly I am not running run. I am doing with T1 and T2. This is another way of doing. This is a very smart way of doing things. T1 and T2, these are threads directly with the thread class type. I will just open this. Simple, very simple. I will say thread. Oh, I do not need that. Yeah, because I've already defined like this. I've only defined like this. I will say, because it is a thread, I cannot say run directly. Can I do that? I say that since T1 and T2 are created from this lambda expression, I will say T1 dot start. I can give a sleep method and T2 dot start if I want to get a synchronization out of it. Let's see. Will it work? I don't know. Let me try. Yes, it is working. And let me try giving -2. Will it work? Yeah, it will work, but whether it will work in a synchronized manner. No, because this time is too less between between T1 and T2. So we are not being able to synchronize it between these two. Okay. My objective was to synchronize between T1 and T2. Let T1 complete its job, then it will start T2. But in between, I need to give some gap such that it has enough time to complete its activity and then it will start. But here, because I have given sleep of -2, it has too less time to execute this. So it could not complete the entire thing. It printed one high, but then this thread 2 had taken over. Thread 2 got a slice of time from the CPU, and thread 2 within that time, it has executed all the 5 hellos, and thereafter the remaining 4 highs are printed. But my concept of using lambda expression and thread object has worked. We have seen how we have done the implementation of runnable and all those. So if you tell me, do I need this anymore? Can everybody tell me? Because I have used a lambda expression. My question is, let's see, so less number of code. So what is the use of this? Because I have created this object T1, T2 through a very smart way of using lambda expression. And so do I need to have this class separately? You tell me. If I make this off, will my program not work? I am not creating any class. Why do I need to create any class? Because I have used anonymous thing or an abstract method to do the entire thing, to create the object. If I create the object at the runtime and do my activity there only, so why do I need to create a reusable class again and again? Will it work?
Yes, sir.
Yes. Let me see. Let me clear this. Yes, it is working. So now, can you imagine that I have one line, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. In my 24, 25, 26. In 26 line of code, I have completed my entire thing. I have not created it. So all these things I have saved. Do you think that this is smarter enough? And this is the one that is preferred over writing so many things? Because your objective is fulfilled. So why to write so many lines of code to get the same result? So this is the way, the smartest way of using lambda expression and all the stuff. So now you use that. See, once I have a parameterized function, parameterized constructor, and that constructor, that parameter is nothing but a runnable target, or which is a interface. I have to pass an interface within that parameter. So I can, and that interface is also a functional interface. So I will use Lambda expression because I know I have only one method within that, one abstract method within that functional interface. So that's why I am using. So it has given me lot of execution speed. It has given me a lot of shortening of the code, and it has given me, see, it's very maintainable because anybody who knows about Lambda expression will be very happy to maintain this. Because otherwise, if he finds so much of a code for this much of an output, for a simple output, this guy has written a big code, he will not be happy. And this code checker will also not pass this thing. Because it is maintainable, this is error free, and this is performance wise is very good. Are you happy?
Yes, sir.
So, but I think, yeah, only just looking at this will not help. You have to try out this code at your house. Okay. You have the Eclipse interface, Eclipse IDE interface. You write this program, try to do it yourself, try to change things and see the result. That is the best way to understand this. So once we understand this multi-threading and the Lambda expression, we have to know now, see, I'm going towards, see, this is, we are doing this somehow by manipulating the sleep method, right? We are giving a trial and error method between the sleep time that we would like to give, such that this synchronization is happening between the two threads. But there can be number of threads. So it is very difficult to use sleep method to get a result of synchronization. It's simply not possible. So therefore, we need to know, see, both the threads come to the CPU and asking for the time slice. Will the CPU have any way to determine who should be giving which thread should be given the time slice first and somebody else the next? There is no way for the CPU. But if the CPU knows by the thread priority something that yes, this thread has a higher priority than the other thread, so it will give the time slicing to that first. See, both of them has come to use a resource at the same time. It can happen with threads, you do not have any control. So any thread will, multiple threads can come to the that CPU asking for the time at the same time, at the very same time. So will CPU have any method? It will randomly assign, but randomness is not a preferred objectivity in our code. We should know that I should give a priority to this thread because this thread is more priority to me or for that process. So that way I will arrange the priority. So to know that, I have to go through this example. So because I have a thread, which is a class, I will get something of functions. First of all, I can also get the priority, which is all implemented within thread class. There is get name, set name. This is the get name. I can get the name of a thread. I can set a thread name. Because till now, did we name any thread? Like this T1 and T2 is just an object, but we have not given any name to that thread. Here we will try to get a name to a thread, because sometimes we will understand the thread by the thread name. Sometimes we will understand the thread with the priority. We can get the priority. We can set the priority. And we can also know which thread is running right now. So what is the current thread? These are the functions. Because we are using thread, the class. So we can understand the get name, we can set the set name, we can get the priority of the thread, we can set the priority of the thread, we can say current, which thread is running now, what is the current thread we are running. All these methods are there within the thread class. I am using a thread name priority class where there is a main. I'm saying that thread T1, this is an object. I am using a new thread. And we have learned this right now. We are actually implementing the run method of Runnable Interface. For int 1 to 5, again, the same thing. But here I have introduced something else. I'm saying, yes, I'm going to print high, but at the same time, I'm going to say that the current thread, and this is the current, if thread, this is the current thread, what is the priority? Printing the current thread priority. I will stop the sleep now. I have given this, and this object has been created. What is the name of the object? I say that the name of the object here is high thread anonymous. Just any name. Because this is an anonymous class. Because we have used a abstract. See, abstract method can only be derived from an anonymous class. And this anonymous class was runnable. I have given any name. I can give I can also give like this. So I have given this thread T1 a name called Java Team 15, maybe 1. And here I can mention this one I say hi, and this one I say this one I'm saying hello. To differentiate, just a name. So this T2 has been given a name Java Team 15 hello team and Java Team 15 hi team. Okay, let me see. So now what I will say, thread name, get name, and set name methods. I'm trying to use that. I'm saying print one, get name. And then I say T1, I'm setting a separate name called high thread, and T2, I'm setting a name. So this name will change because I have set the name. But here, while creating the object, I have given a name, so I will get the name like this. I change the name with the set name because they are set, they are threads, T1 and T2. Now, when I print the thread names, I will get high thread and hello thread. Here I will get Java Team 15 high. Here I will get Java Team 15 hello. Then the priority. I will first of all like to know what is the priority for the current thread. So system out print line T1 priority, T1 dot get priority, and T2 dot get priority is, I will tell you the priority range minimum is 1, normal is 5, and maximum is 10. I cannot go between less than 1 or more than 10. But when I say I have not set the priority, did I set the priority anywhere earlier? No, I didn't set. So what will be the priority? Both the threads normally will have the same priority, and that is the normal priority, which is priority number 5. That's why when both of them, T1 and T2, goes to the CPU to ask for time slicing, how will the CPU understand? Because both of them will have a priority of 5. So it will have a round robin logic to algorithm to assign the time slice. Okay, T2 will get time of say 12 12 and 24 minutes, it will start, and that will get 12, 24 minutes and 15 seconds. It has its own logic. But once you set the priority, let's say you are setting the priority T1 to 1 and T2 to 10. That's the highest priority. So whenever both of them come to CPU, CPU can easily understand that this is of highest priority. I must first give the time to T2, then only I will give the time to T. Or you can use these constants. You can say T1 set priority thread mean priority. You might not, because you might not know what is the minimum priority, whether it's 1 or 5 or 10 or something like that. So always use a constant. This constant is exposed in the library. It knows that min priority means 1, norm priority means 5, and max underscore priority, all in capitals. Constant is always the casing rule is always with all capitals. Now, after you have set the priority, you say T1 priority, you can get the T1 priority and T2 priority. Now, all these things after you have set, see, these are already, this is just created. You have not executed. So as I said, you will not do it automatically. You have to do this T1 start, T2 start, T1 join, T2 join. Now, what is join? Join, with this join, what I'm saying is, it is like the closing of the resources. What you do with the try with resources. You try to close the resources because you have started, you have created a thread. Thread is a resource. So you must close it as well. So what always best practice is, if you had not given this, no harm. Compiler will not complain, runtime will not get any error. But you are still, you have created a thread, you have not stopped it. So how do you stop it? You stop it. There is no stop command. Like T1, you say start. You cannot say stop. There is no such command. Stop has been deprecated. Deprecated means is no longer used. Instead, you have to say join. Got me? Correct? So you are basically stopping or closing the thread which you have opened. Otherwise, the thread is still open in the memory. Thread is, after all, T1 is an object, T2 is an object. Are you closing it? No. You have to close it by using join. Join means this thread, this child has joined back to its mother, which is, what is the mother? Who is the mother of T1 and T2?
Thread.
Sorry?
Thread.
No, not thread set. Thread set is just a function.
Thread.
Acha, you say thread, the mother. Okay, yeah, that is one very good question. Very good answer. I will. But here, what I meant was the main. Main is a thread. Within main, you have created two children, T1 and T2. So mother of T1 and T2 is here main. And who is the mother of this main thread? Is the thread class. Yes, you are indirectly very correct. Very correct. Okay. So it joins back to its mother and therefore it sleeps. It is destroyed. And therefore the resource is closed. And then you say bye. Let me execute this. Let me see. Okay. Now you have set the name. You can get the name. You can set the priority. You can get the priority. Okay. Now, let us first go here. You have created two threads. Now, this will not be executed initially. Why? Because you have just created the object. You have not executed it. You have not started the thread. You have created. First line is this one. This is the first line. So what is saying? The T1 name, yeah, Java team 15 high, because you are trying to get the name. What is the name set for the T1? Java team 15 high. So it is printing high. Similarly, for T2, it is getting the name as Java team 15 hello. Now, you are setting the thread. For T1, it is high thread and hello thread. So whenever you print out, you say T1 now, the T1 name is, thread 1 name is high thread and T2 name is hello thread, correct? You are getting the priority of T1 and see, both of them are T1 priority, and because I said we have the normal priority set by default. So 5, 5. Now you are setting it to 1 and then 10. So it should print 1, but it has printed 5 because here you have, see, you have set the priority, mean priority. Yeah, so T1 is 1. But at the very next line, you have set again the priority to non-priority. So it became 5, correct? And you have set the priority of T2 to 10. After this, you are trying to get the priority and you have got the priority. Now you are starting. Once you start T1, you have started T1. So it will go to that loop. It will print. It will print high. And not only high, it will give you the priority as well. So high has been set. That is the first T1 has been set to 5. This one. So it is saying high 5, high 5, high 5, high 5, high 5. Okay. The same program, I'm just changing so that you know, understand. And then T2, and between that you have tried to do some synchronization between T1 and T2. You have given the sleep time. After that, the T2 starts. After all the 5 highs, high 5 is printed. Hello 10, hello 10, hello 10, hello 10, hello 10, and then bye. Hello 10, why? 10 is the priority set. T2 set priority, thread max priority, which is max priority is nothing but 10. Okay, are you fine with this? Setting and getting priority and name. And you also use current thread. Current thread is this one. That means you want to understand which one is this thread. Thread dot current thread. Current thread is a function within the thread class. And then again, current thread is having a sub method within that, calling a sub method called get priority. It will get the priority with whatever it has been set. Last thing is the synchronization. That is what our objective was. That yes, we will spawn hundreds of threads, but I will try to achieve some form of synchronization between the threads. That is the main objective, because it is very difficult to control threads, control the activity of thread, because you do not have any way to synchronize it. Yes, but Java has given you a solution. If in C or C++, if you were trying to control the thread to achieve some sort of synchronization, you will face a lot of programming skills or a lot of hard work. It is not very easy to achieve. But in Java, just now you will see how simple it is to achieve that. So you must thank Java for giving this beautiful world of programming. It has made the life of programmers very simple, made life easy for them. If you know C pointer, sometimes some programmers will find it nightmare, simply nightmare, to understand how a pointer or a double pointer or triple pointer works. Memory addressing is not a very simple task. Here you are free. Java has made you free from all these hassles, all this hardship. Now, till now, did you have to know about pointers? You are doing such a lot of marvelous things over the memory, but not for a single time you have to write anything with pointers. Let's say you have a class called counter. It's a very simple class, normal class. What is the objective of this such that this is going to be incremented with a function called increment. Somebody will increment the count. Somebody will access this increment function of counter class and increase the counter by 1 each time. So we are basically thinking of a situation where many threads will access this method and will try to increase this counter. Some activity is doing, and when the activity is completed, it is coming here, accessing this increment and incrementing this such that there is a count. So from a food counter, so many bearers, there are so many tables in a restaurant. Okay, so many people are giving order for food. So table number 1 has given an order, table number 12 has given an order, table number 90 has given an order. Let's say 90 tables are there. And in between, everyone has come and given order. Each of these being carried over and placed somewhere, their order has to be placed. So somebody has given a non-veg thali and somebody has given a veg thali, somebody has given a chow mein plate, somebody has given this thing, so many orders. So this will be processed separately. It will go to the kitchen for the order and with the order number and everything will be done. But at the counter, somebody is counting that, okay, this order number 1 has been served. So it will increment the count by 1. That means 1 table has been served. So if there are 90 tables, they will not be served the food at the same time. You see in any restaurant where you go and everybody is served the food the same time? No, because they come at different times and this and that. But at the end of the day, the counter manager will try to find out how many counters or how many foods did we serve in total today. So during the processing, so the bearer comes and said, sir, I have served that table. Okay, so the counter manager will increment the count by 1. So every now and then some bearer will come and the counter gets achieved. Now suppose at one point of time 5 bearers come to the counter. 5 bearer has come to the counter at the same time. 5 boys have come to the counter and say we have served there. So what will the manager do? Will it like when it is incrementing the counter of 1, counter by 1, another person has come at the same time. Can it increment by 2? No. So let's say total was 20 at that stage. It has to make it 21, then it will make it to 22. So sequentially. So till the time it is making it 21 plus 1. Plus 1 is also going to get some time of the processor, of the CPU. So that time is reserved. It will not allow the CPU to process another counter. Let's say 10 threads had come to the CPU to access this increment function. It cannot give the another thread to access unless the previous thread has completed the count by 1, incremented the count by 1. Once it is released, then the next thread in the queue. This has to be synchronized. If it was unsynchronized, nobody will know what is the last count that I have to increment. Are you getting my problem? Getting the problem? If I do not have a synchronized method of control to this function, then I do not know now what is the current value. Is it 20 or 21 or 22? So whether it will be 20 plus 1 or it will be 21 plus 1 or it will be 22 plus 1. It's very difficult. So 1 thread has come, 5 threads have come. But what was the last thing? Last thing was 20. So say whoever has got the priority, or not the priority even, that it will allocate 1, but whichever thread has been allocated to increment 20 plus 1 will only complete, that thread will complete this one. Then only the next thread will work on 21. Because these have been released, the result now is 21, and then the second thread will increment it to 1. Suppose if both of the threads were trying to increment 20 plus 1, what will be the result? It was supposed to be 22, but you find that it is now 21. Because 20 was incremented to 21, but somebody else at the same time has done plus 1 with 20 again. So 2 threads had made it 21, whereas it should have been 22. You're getting me?
No, sir. Please tell me one second.
Acha. Okay. Let's say my value now is 20. That the count value right now. Let's say current thread. So a current thread, a thread has come to this to use this method increment. It will say it will increment it to plus 1, right? So what will be the result? 21. At the same time, when the thread 1, let's say thread 1 was doing this. This was done by T1. Just to differentiate. Now, at the same time, there was another thread which has access increment at the same time when T1 was working on it. So let's say it will also find what was the last value. It will say it will find 20. It will not find 21 because thread T1 has not completed. If the CPU allows, then it will allow T1 to do the same thing. Equal to 21. And now this is T2. So end of the operation, when both T1 and T2 has completed, what will happen? What will be the result? The result is 21. Whereas it was supposed to be 22. Think logically.
Okay.
22 tables should have been served, but the manager has quoted because manager has given at the same time both of the boys have come to it, and the last result was 20. The boy T1, let's say the boy's name is T1, has said that I have served it. So manager says 21. But when manager was quoting this 21 or registering this value, another boy came at the same time, and manager has incremented this 20 to 21. Whereas it should have completed this task, then processed the request of T2. Then it would have been 22. Otherwise, it will end of the day. Suppose five boys have come at the same time. Even after processing 5 boys, what will happen? It may happen that the result is only 21. After 5 threads have tried to increase the counter by
Same time.
1. Same time.
Okay.
So if it happens that it may be 21, or sometimes it can be 22, it can sometimes be 23, it can be 24, it can be also 25. That can happen. But most probably you do not know whether it will be the final result. Your target should have been 25, but sometimes you might get 21, sometimes you might get 23, sometimes you might get 25. Yes. But if you get 21 or 23, your result is wrong. You should always get 25 because this increment has to be synchronized. And Java has given you a solution. Otherwise, you have to implement the mutex method of C. And it's a very, very hard, very difficult concept to grab. Understand? But by simply adding one clause called synchronized, that accessor, that modifier, synchronized, what I'm doing is I'm making this function synchronized. That means this function will not give it to another thread processing unless the previous thread processing is complete. I cannot leave this incomplete, and whereas other thread comes and tries to increment it. Like like in a database, think of a database. If it was not synchronized, what will happen is there are hundreds of users using the same table. You try to understand. You are in the IT field. It is not a very ideal situation. You cannot always think in terms of monologue. That is not a one traffic, single traffic thinking. You have to think of a road where there are hundreds of cars. You have to cater to something which is very synchronized. If a lane will allow, if you have a rule that you allow in a single lane, any number of cars can go by the single lane, then what will happen? There can be a possibility of accidents. That's why you say you divide the lanes. You have a 3-lane. 3-lane means 3-lane road. That means each lane at the same time parallelly, 3 vehicles can move in parallel, not 4. In 3 lanes, you cannot have 4 cars or 4 vehicles. That is the rule. That is the rule, such that you avoid the accident. So if you not do that, what will happen? Somebody else will try to overtake somebody, and there can be a possibility of accident. Accident means there is an unpredictable result. You do not predict it. But here, if I cannot predict the result, there is a problem. Therefore, see, in a banking transaction, if it is not synchronized, okay, or in a database table, if it is not synchronized, at the same time, 100 users are writing on the same table. There can be 50 users who is writing on the same row. Some 50 users is updating something. So it is updating on the same row, maybe. Okay. So what will happen? The person who has written very last is the updated version. That means something has to say, say your account has been updated by your son, your daughter, and because everybody has an access to your account. Okay, and you yourself, your this thing. But it may happen that at the same time, your son, your daughter, yourself, and your wife is putting in money or extracting money. So what will happen is the same row, your account is the row that each row will be affected unless it is synchronized. That means one transaction should be completed before you start another transaction. So you have 100 rupees in your account and your daughter is adding another 100 rupees and your son is adding another 100 rupees. But if it is unsynchronized, so if your daughter is adding 100 rupees, it should increment your 200 to 100 to 200. Your son has increment, but if they have done this at the same time, it may end up that your increment has happened only once. Either your son has incremented by 100 rupees or your daughter. So the net result, instead of getting it, the account balance should be 300. Instead of 300 is 200. Is it an acceptable behavior? If the banking system allowed like this, will you be happy?
No.
So banking system should only whenever somebody is some function, your transaction, some function is happening, right? Your application has given access to your son to use a function like depositing money. Deposit is one function. But depositing at the same time, your daughter is also depositing at the same time. So let it be whoever, but at the time of processing, I will lock it. I will lock the row so that nobody else can update, modify, delete. Isn't it? I will lock it. Synchronize is locking effect. to enable the locking effect. That at the time of processing of this increment, I will not allow any threads to work on this. By synchronized method, synchronized clause word, I am giving a locking effect to this such that at the point of interaction or the processing, I will not allow anybody else to work on it. So each time I will receive an increment of 21, 22, 23, 24. Okay, the desired result will be there. But let us run it such that we will understand. What I'm doing is I'm creating a class, object C with the class counter. It's a very simple thing. I'm creating two threads, T1, T2. I know it is run method. I'm doing fine. I'm not doing a Lambda expression just to make you understand. But I have to say runnable because thread constructor will take the runnable target. Fine. I've done that. Basically, I'm creating an object T1 by passing an runnable object obj1. You are getting me? You could have done this way also. Runnable obj1 equal to new runnable, and then you know that Lambda expression. Okay, you can do that, and thereafter you could have said obj1. Instead of doing that, what we are doing that is the same thing. I am doing it in one single way. I'm saying new runnable and then giving the run implementation run method. That's all. And then at the very end, I say this bracket and a semicolon. Don't miss the semicolon. If you miss the semicolon, there is an error. I will get an error. Syntax error. Insert semicolon to complete local variable declaration, local variable. So I have to give a semicolon. Similarly, I am creating T2. Here I am running it for 1000 increment. So finally, this main thread is spawning two thread to increment, to use this function increment. This function increment will increment the count by 1. Correct? You know this one. Plus means count. This is nothing but count equal to count plus 1. Either you write this or you write this. Okay. Same. Now, so what do you expect? What do you expect? Because you have used synchronized. So would you not say that T1 will first of all work on this increment it, because it has access to synchronized function, it will complete the entire, whoever holds up, because you have started T1 first. So T1 will get an access to increment, and T1, unless T1 completes its operation, will you be able to start T2? No, in this case, no. You do not have to give a sleep time and this and that. That's why we are not using sleep. Because here you have used a Java synchronized clause. So leave it on Java. Java will handle it much more better than how you manipulate on sleep. It will not leave this increment function of T1 unless T1 completes it. So what will be the end result of this thing? What will you get? What will you get? Let's say int is actually 0. So whenever you are using C and increment, T1 will increment it to how much? End of the result of this thing will be what? What will be the count value? Count equal to, yeah,
1.
1. But I'm
1.
repeating this increment for 1,000 times.
Okay, 1,000.
1,000. What will be the value of count here?
2,000.
How much?
2,000, sir. Up to 100.
Yes, 2,000. It is not 1,000 again, because here it will start from where T1 has left. T1 has left the value of count to 1,000. So T2 will start 1,000 plus 1, 1,000, 1,001 plus 1, 1,002 plus 1, that to 2,000. Am I sure? And joining is just like as I said. So finally you print the count. Let me see. I'm using synchronized. Fine. Let me see what's happening. Count is 2,000. I'm running it again and again. See, did I give sleep or anything? But every time I will get 2,000. There is no doubt how many times you execute and how many way you execute. Doesn't matter. Because it will, whoever accesses this increment, since it is synchronized, I will not allow anybody, anyone else to access increment while T1 or T2 is processing it. Correct. Now I just simply take this away. Okay. I take it away. I have not given any sleep or anything. Let me see what happens. So now I expect that I do not have any control. So will you expect 2,000 every time? Sometimes yes, sometimes it can be 2,000, but it is very hard, very difficult to achieve 2,000 every time. Are you getting me? What I'm trying to drive?
Yes, sir. Yes, sir.
Do you see? First time it had given 2,000. Fine, it's an ideal situation. Then it gave 1616. But is it the desired result?
No, sir.
No, I wanted to get a value of 2,000. So 1616 is, or anything less than 2,000 is less. It will never be more than 2,000, but anything less is not acceptable. So unpredictable. I do not know. I cannot guarantee that the result is always 2,000. No, I can never. But I can guarantee this. That is the difference between how you control, whether you want to achieve the synchronization. So synchronization is not only achieved by time because it's difficult. Even if you adjust the sleep time, you still cannot guarantee that it will be the behavior. But if you say synchronized, void, output is void. I don't want to return any output. Then I am assuring, because Java is assuring that every time the count value is 2,000. Every time. Number of times I run it. You see, never one less than 2,000. Is the concept clear? This is all that you need to know in threading, multi-threading. If you can understand this part well, what is joining, what is start, will the start, there is nothing like start. So it directly goes to run of runnable interface. So that run. That's all. These are simple concepts. But if you know this, what is synchronized? How will you achieve synchronization without using sleep? Yeah, you say, and we will use the reserved word synchronized. So are you happy with this? The next day, we will start one very important topic, collection. I mean, the collection framework of Java. Okay?
Okay, sir.
Try to practice these things because these things are very important to understand for an interview point of view. If you understand the synchronized, the priority, and the Lambda expression, how do you do that with a functional interface? What is multi-threading, runnable interface, thread class? Nobody can beat you in an interview. Okay, so today we end our class here. Maybe tomorrow we will have the next session. We'll start a very important topic. Try to join, try to understand, because collection, Java core, if there are 7 questions, you almost get 4 questions, 4 to 5 questions out of 7 from collections. It is so important. We will understand it thoroughly like we have understood the other subjects, other topics in Java. Any questions?
No, sir. No.
Anish?